Hello Year 12 and welcome to our next video here for trig equations. Today we're going to look at the sum of sine and cosine functions, and the curious thing to note here is that if I have two sine and cosine functions with the same period, perhaps a different amplitude, and I add them or subtract them, then I produce another sine or cosine function. Easy as that. Same period, different amplitude, probably. Now I can express that in any one of these four ways. R sine x plus alpha, R sine x minus alpha, R cos x plus alpha, or R cos x minus alpha. Okay, so they all just have a horizontal translation. Okay, if I have an equation in the form A sine x plus B cos x. Now, we could use any one of those four, and sometimes it'll be specified, such as in this first example. We've been asked to express this function y equals 3 sine x minus 4 cos x in the form of y equals r cos x minus alpha. Rightio, r is positive and alpha is somewhere between 0 and 360 degrees. So we kick it off like this. I'm going to say let y equal r cos x minus alpha. Therefore, let's say 3 sine x minus 4 cos x is equal to r cos x minus alpha. Now, cos x minus alpha, if we remember these composite angle formulas, I can expand that. So we're going to say that 3 sine x minus 4 cos x equals r times cos x cos alpha plus r sine x sine alpha. Go back and check that that identity if you need. Okay, but that's that expansion there. Cos a plus b, if you like, is cos a cos b. Oh, a minus b is plus sine x sine a sine b. So I've got this. And now comes a little bit of a tricky thing where we equate the coefficients. I've got 3 lots of sine x here on the left. And how many lots of sine x do I have on the right? Well, I have r sine alpha multiplied by sine x. So therefore we can say that r sine alpha equals 3. We equate the coefficients of the sine x terms. Similarly, the cos x terms, right? The cos x term here has a coefficient of negative 4, and here r cos alpha. Cos alpha equals negative 4. Now from there I'm going to square both of those and add them together. So I get r squared sine squared alpha plus r squared cos squared alpha equals 3 squared plus 4 squared is 9 plus 16. We can write that. Now, if I factorise this, take r squared, I'll have sine squared plus cos squared, and sine squared plus cos squared equals 1, so I just get r squared equals 25, and because r has to be positive, I'm going to say that r equals 5. That's very helpful. Substitute that back in, and 5 sine alpha equals 3, so sine alpha equals 3/5, and cos alpha equals negative 4/5. Okay, now, if sine is positive, cos is negative. Second quadrant, our answer has to be between, right, we're looking for answers between 0 and 360 for alpha. So we're after a second quadrant answer here. That's not an exact value. I'm going to have to pull out the calculator here. And so let's grab that calculator. Make sure that it's in degrees. And I'm going to go the inverse sine of 3/5. That, of course, is going to give me a related acute angle, which is about 37 degrees. But I want a second quadrant answer, so I need 180 minus that. About 143 degrees. That'll do us for today. That means that my equation is y equals 5 cos of x minus 143 degrees. Very good. Now from here we're asked to, that's part A done, we're asked to sketch this only over the domain from negative 180 to 180. And we can see here that we have a cos function with an amplitude of 5 that has been horizontally translated. It's been moved to the right by 143 degrees. Now, normally I would draw quite a lot of this graph and then rub some out, but it doesn't work very well on the screen, so I'm just going to have to sort of take it for granted that it looks a bit like this. Righto. Now, that point there would normally be at 0, 1, okay, on our basic reference cos function, but it's been vertically dilated by a factor of 5, amplitude of 5, and it's been shifted to the right by 143. So the coordinates of that turning point are at 143, 5. Similarly, this one down here would normally be at negative 180. So when I go forward by 143, that goes up to negative 37. So negative 37, negative 5. Not a lot of room here. My mean runs through the middle. Right, there's my x-axis. It's going to have a closed circle here and here, because it's equal to. Now, my y-axis will go about here. Right, now we're asked to label all of these points here. My x-intercepts would normally occur, this would occur at negative 90. Negative 90, if I go forward 143, that's at 53 there. And negative 270 plus 143, remember, translating to the right, is negative 127. This here, of course, is at negative 180. And if I substitute that into the equation, we'll find that I end up with a y value of 4. I can substitute x equals 0, and I get negative 4 here, and 184 there. Righto, that's all my turning points, all my intercepts, and my endpoints. Righto, a little y here. Okay, that's our sketch. Rightio, now for, where are we up to? Part C, solve for this equals negative 2. Now let's just have a look here. If I drew the line y equals negative 2, it'd look something like this, wouldn't it? So I expect there should be a solution here somewhere, and here somewhere. So just a rough guess now, I'm looking for an answer that's somewhere between 0 and 53, and somewhere between negative 127 and negative 37. Right, it helps to sort of see what's going on there. So what we're going to do is, I'm going to say 5 cos x minus 143 equals negative 2, means that the cos of x minus 143 equals negative 2/5. Rightio. We better keep an eye on the domain. We're after from negative 180 to 180, but I've got an x minus 143 here, so x minus 143 right, is going to be between 180 minus 143. What's 180 minus 143? Negative 323. On that end, and on this end, right, it's going to only go up to 37. Right. So, x minus 143. I've got to find these solutions in here. So, cos is going to be negative in the second and third quadrants. Positive in the first and second. Second and third quadrants that fall into this range here, none of the positive answers, not the 37. So, I'm after a solution that is negative 180 plus the inverse cos of this plus this related acute angle. Right, so if you like, I'm going to be after these angles here. That's going to be my related acute angle here and here. And I'm after this one and that one. Okay, so pull out the calculator again. All clear. If I do the inverse cos of negative 2/5, inverse cos of negative 2/5, gives me 113. No, that's not a related acute angle, is it? Okay, so if I do the inverse cos of 2/5, inverse cos of 2/5 gives me a related acute angle of about 66 degrees. Now you've got to be careful with the rounding off here with these things, but that's going to do us for the example. So, back to our little diagram here. I want to come negative 180 forward by 66. So, I'm going to go negative 180 plus, just going to, oh, whoops, no, delete that one, a little awkward here. Okay. Negative 180 plus my 66 is about negative 114. So we've got x minus 143 is equal to negative 114, or x minus 143. Now it's going to be negative 180 minus that 60. Right, okay, so negative 180 minus minus my, was it 68? 66. Okay, negative 246. In that case, x equals, righto, so now I'm going to add 143 to negative 114. Negative 114 plus 143 gives me, no, negative 114 plus 143 equals 29, or x equals, let's grab this one, all clear, negative 246 plus 143 equals negative 103. Coming back to our little graph here, does that look good? Yeah, that seems pretty reasonable, fits within the ranges that we wanted. So, if 3 sine x minus 4 cos x equals negative 2, then x equals 29 or negative 103, or thereabouts. Now, the very last bit that we need to do here for part D is really going to be quite easy. Look at the graph. I want to know when my function is less than or equal to negative 2. So it's just those bits there between, right, we've determined negative 103 and 29. So I'm going to say that negative 103 is less than or equal to x less than or equal to 29. Okay, so all of these tend to follow a fairly similar pattern. Get them in the form of a sine x plus b cos x. Then typically you can choose whichever of those four formats that you like. Sine x plus alpha or sine x minus alpha, cos x plus alpha, cos x minus alpha. Determine the size of r, determine the value of alpha, and see what happens after that. Rightio, that's it. If you've got any questions about this, make sure you jot them down so we don't forget, and I'll see you in class.